All right, so we're going to derive this identity. N choose 0 plus n choose 1 plus n choose 2 plus dot 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 all the way to n choose n is equal to 2 to the n for n bigger than or equal to 0. And the hint is that we're going to let a equal b equal 1 in the binomial theorem. So remember, the binomial theorem states that for any real numbers a and b, right, a plus b to the n is equal to the sum from 0 to n of n choose k, a to the n minus k times b to the k, right? And this works for any n greater than or equal to 0. Okay, so let's go ahead and start the proof. So as you can see with our hint, we're going to look at a and b be 1, right? So that's our real number. So 1 plus 1 to the n is equal to the sum from 0 to n of n choose k, 1 to the n minus k times 1 to the k. All right, so clearly we can see that 1 plus 1 is 2, so this is 2 to the n is equal to. So let's look at the first few terms, right? So it's going to be n choose 0, right? And then 1 to the n minus 0 is still 1, and 1 to the 0 is 1. So this is the first term in the series, right? Plus n choose 1, right? Because it's going to be n choose 1. And then 1 to the n minus 1 is still 1 times itself, n minus 1 times, which is still 1. And 1 to the 1 is 1. And then, of course, let's do this last, or we'll do the third term in the series, right? This is going to be n choose 2. And this is going to be 1 to the n minus 2. Again, 1 times itself, n minus 2 times is still 1. And 1 to the 2 is still 1. So, right, we can repeat this. So, plus, dot, 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 plus. And then the last term of this series is going to be n choose n. And then 1 to the n minus n is 1 to the 0, which is still 1. And 1 to the n is still 1. So we get 2 to the n is equal to n choose 0 plus n choose 1 plus n choose 2 plus dot, 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 all the way to n choose n, which is exactly what we wanted to show using the binomial theorem.